Okay. Okay, I'll start. Hello, everyone. Here is Group B. And my name is Zhang Chun, and my metric number is 8206957. I'm the moderator in our team, and our team's purpose is life below water. That is the SDG 14 purpose in UNEP. This purpose focused on some problems like plastic pollution, overfishing, and ocean conservation. And our team's purpose need to divide that into 4 subtopics to explain. As for my focus role, because I'm a moderator, I need to provide a global SDG 14 overview, guide discussion flow, summarize findings and conclusions. So as the sources I chose, the sources UNEP 2093, Measuring Progress, Water-Related Ecosystems, and SDGs. And here is the links. And the reason why I chose that source is because I think this is the official UN source and SDG focused and highly relevant to our topic. And the article has rich data, updated indicators, and strong structural logic. It's very useful to explain this purpose. So how I will use them to show my ideas. First, I open the discussion using global UNEP data. And second, justify the choice of 4 panelists subtopics. And third, support transitions and logic flow. And last, frame the concluding remarks and recommendations. Yeah, that is my oral report. Thanks a lot.
Okay, hello everyone. I'm Yang Jingying. My metric number is 8207444. My task was to research how plastic hurts ocean life and find ways we can help. The first one, the article I chose, I found a study called Plastic in Our Oceans, a flooding problem by Dr. Marcos. It's from a science journal called PLOS One. The main point is simple. There's way too much plastic in the ocean, and it's breaking into tiny pieces that fish eat. The second one, what I did for our group. As a solutions finder, I focused on 3 things. The first one made it relatable, turned complex science into easy to understand point, like show how plastic bottle cap can travel across the ocean. Second, connected to daily life, researched how our cafeterias, the disposable containers A2 Carbon suggests we tracked our own plastic use. Second, Found Hope Sports looked up our success stories like how Indonesia reduced the plastic waste by working with local fishermen. Okay, last but not least, why this matters for us. This isn't just about sad facts, it's about what we can do. In our discussion, I will share a simple 2-minute challenge idea I created picking up 3 plastic items daily. My research helped connect our school habits to bigger ocean health goal. Okay, it's my whole next.
Okay, my name is Wen and my metric number is 8206915 and my topic is how to deal with overfishing. So, as we all know, fish is the main source of animal protection about 40% of the world's population. From the ancient time when humans fished with their bare hands to the present when we use various advanced tools for deep sea trawling in the open ocean, our exploitation of fishery resources has never stopped. However, nowadays the number of overfished fish population globally has tripled in half a century, and the catches of one-third of commercial fish species has exceeded their sustainable limits. So take the Grand Banks of Newfoundland in Canada as an example. There was once legend that one could walk ashore on the backs of cod, but now it has fallen into a fishless tragedy because fishermen always choose to catch larger cod. The size of cod has become smaller and smaller, and the population has been shrinking and even facing disappearance. Looking at the small yellow croaker that we are familiar with. In the 1950s, the population of sexually mature small yellow croakers about 1 year old was only 5%, which changed to 40% in 1980s and expanded to 74% to 100% at the beginnings of this century. They are trying to their best to adapt the changes in the external environment, but if fishing methods do not change, it may eventually lead to loss of the population. Commercial fishing has a more serious impact on species with low reproductive capacity and slow growth. Thanks to the anthem of shark fins in Asian market also brought the population of scalloped hornhead sharks near the Great Barrier Reef in Australia to an end. The reduction in the number of fish caused by overfishing is just the beginning. It also affects the genetic diversity of the population, reduces their potential to cope with long-term environmental changes, and it changes the role they play in ecosystem. Although no marine species is known to have become extinct slowly due to fishing so far, the impact of fishing operations on commercial fish has triggered a domino effect, making the ecosystem more valuable when facing their further environmental changes. Fishing is a better industry in many countries and many people make a living from it. But for the sake of underwater life and the future of the earth, we must find solutions. Fisheries management need to create a win-win solutions. It's necessary not only to regret the population of fishing species, but also manage a higher level in terms of capital, market prices, and fishing technologies. So as to maintain the fishery economic level while reducing the fishing volume and achieve the long-term sustainable development of fisheries. Let us take action, pay attention to the problem of overfishing, support the development of sustainable fisheries, and create a beautiful future for underwater life. Thank you all.
Okay. Hi, everyone. I'm Lucifer from Group B. My metric number is 8207208. Today, I want to talk about an important issue that affects marine ecosystem worldwide: coastal eutrophication. This might sound technical, but it's simply about how too many nutrients getting into our coastal waters can cause serious harm to ocean life. Here's the template. Next, I'll explain clear what eutrophication is, the jeopardization, what we can do for ocean environment. I'll also use findings from the study from the globalization of cultural eutrophication in the coastal ocean, causes and consequences by Malone and Newton to back up my point. So what exactly is coastal eutrophication? Coastal eutrophication can happen when coastal waters get overloaded with nutrients, mainly nitrogen and philosophers. These nutrients mostly come from human activities, like agriculture, especially fertilizer, untreated sewage, and industrial pollution. According to Malone and Newton, around 24 of human-produced nitrogen from watershed actually ends up in coastal ecosystems. When all this nutrient flows into the ocean, they encourage rapid algae growth. This is called an algal bloom. At first glance, algae growth doesn't sound too bad, right? But as we'll see, it creates big problem. Now, let's look at why coastal eutrophication is harmful. Algal bloom can lead to several major issues. First, when all these algae eventually die, bacteria start breaking them down. This decomposition process uses up oxygen from the water, creating what we call hypoxia zones or dead zone. When there's not enough oxygen left for marine life to survive, a famous example is the huge dead zone in the Gulf of Mexico, largely caused by nutrient runoff from the Mississippi River. Secondly, these dead zones significantly reduce marine biodiversity. Fish and other animals either died or must move away, disrupting entire marine ecosystem. Also from Malone and Newton, the text mentions that hypoxia has resulted in habitat loss and the elimination of benthic microfauna over vast areas, disrupting benthic food web. Moreover, eutrophication doesn't just harm ocean wildlife, it also affects human economies. As Malone and Newton emphasize, fishing industries have suffered due to reduced fish population, and tourism declines as beaches and waters become polluted. For instance, toxic phytoplankton event. These events have had a negative impact to fisheries, coastal ecosystem, and public health and coastal economies. The economic cost of this event to the European Union has been estimated to be on the order of 1 billion per year. Finally, what we can do about this problem, the solution and those solving eutrophication requires a comprehensive approach. Firstly, we need better nutrient management, especially smarter agriculture practice and improved wastewater treatment to reduce nutrient runoff. Next, ongoing monitoring and scientific research are essential. Understanding nutrient flows better can help us predict and prevent eutrophication events. Finally, a stronger policy and regulations are needed. Government and international bodies must enforce limits on nutrient pollution to protect marine ecosystem. As Malone and Newton noted that the United States and European Union and China have been responding with management strategies for this problem. To sum up clearly, coastal eutrophication is a serious and growing problem for our oceans. It leads to dead zones, harms marine life, and threatens human health, and damages ecosystem and economies dependent on health oceans. Addressing eutrophication align directly with SDG 14, helping us protect marine biodiversity and ensure the sustainable and the uses of ocean resource. The research by Malone and Newton shows that it isn't a localized issue. It's global and it's getting worse. But by taking clear, coordinated steps now, we can make significant improvement. Thank you so much for listening.
Hello, everyone. I'm Henggang from Group B. Today, let's focus on how underwater life sustains human survival and well-being and discuss its crucial significance for us. And I'm a panelist in this group. Our time's themes is life below water, SCG 14. And my title is The Significance of Underwater Life of Humans. And my articles I choose is Marine Biodiversity and Ecosystems underpins our health, plants, and social well-being. And the other is Christina's Pastels Palmers, and it's from United Nations Chronicles. First, let's focus details. Directions is the core perspective is that on water's ecologies is the lifeline, providing oxygen, food, and stabilizing the climate for humans. The second is the detailed explanations. Underwater life slightly feeds us, but planktons, tiny marine plants, contribute about 50% of the oxygen on Earth, without which we cannot breathe. The ocean also provides 20% of the global proteins, such as fish, and billions of people rely on seafood to supplement their nutrition. Moreover, the ocean absorbs 26% of human carbon emissions each year, while stabilizing the climate and avoiding the threat of extreme water to life. And the third is the supporting evidence. We have oxygen and food. NOAA confirmed the properties of oxygens protected by phytoplankton. And FAO data shows that 3 billion people relies on seafood and their main protein source. Climate regulations. The United Nations report mentions that the oceans absorb 26% of human carbon dioxide, strongly demonstrating its role in stabilizing the climate. The forces of value for the decisions. I focus on the directed connections between our water life and human survivals, oxygen, food, and safeties. Emphasizing these points can help everyone understand that protecting marine ecologies is not just an environmental solution, but is related to what a human can survive. This assures the essentials needs for survival perspective for the subsequent discussing and promotes thinking about the participle significance of protecting the oceans. In simple terms, underwater life is inviolable pillars for human survival, and protecting it is protecting our future. That's all. Thank you.